Now we're going to prove the nth triangular number. So Sn here means nth square number is equal to Tn minus 1. That is our n minus 1th triangular number plus Tn, that's nth triangular number. So notice that we have to require n to be at least equal to 2, because if n equals 1, suppose n equals 1, then we replace every n in this formula by 1, then we get S1 equals T1 minus 1 will be 0. So we're trying to prove S1 equals T0 plus T1. We know there's no such number as T0. The triangle number starts with, all the figure numbers start with 1. Okay, so that's why we have to make sure n is at least 2. So let's write down what we need to prove if n equals 2. We do need to prove the general case, but here it's just the explanation to help you understand how to prove the general case for any n. And so when you do the homework, you cannot just prove this formula for n equal to 2 or n equal to 3 or 4. But what I'm doing right here is to try to kind of help us understand what the formula is. So if n is 2, then we replace n with 2. S2 equals T1 plus T2, which means the second triangular square number is equal to the first triangular number plus the second triangular number. If n equals 3, we replace every n with 3. We get S3 equals T2 plus T3, which means the third square number equals the second triangular number plus the third triangular number. Okay, similarly, you can plug in any number for n. So how do we prove the general case? Sn equals the nth triangular square number equals n minus 1th triangular number plus nth triangular number. So as we explained before, we can draw the graphs like this to show triangular numbers and square numbers. And so here we don't really have to use the graph, because we try to prove it geometrically, not graphically. So you don't really have to draw the graphs here. Here I'm drawing a graph to kind of help you remember what square numbers are. So how do we prove it geometrically? Purely we use algebra. We're not going to look at the graphs at all. So from previous video, we learned the video for the first homework question. We learned this formula, and we also proved this formula in part 1 of the video for this second homework problem. So Tn is equal to nth triangular number is equal to n times n plus 1 divided by 2. And so following the formula, we can figure out what n minus 1th triangular number is. So here we use algebra. N represents the position of this triangular number. So the same for this n and this n. So if you try to find the n minus 1th triangular number, you will have to replace in the formula. So this will replace this n, and this n minus 1 will replace this n in the formula and replace this n in the formula. So we're going to get half on the bottom, and the top n will be replaced by n minus 1, because the position is not n anymore, it's n minus 1. So we replace the second n, the position from with the n minus 1. And now we're going to copy plus 1, which is in the formula. So we simplify this, we get Tn minus 1 equals half of n minus 1 times, and these two will cancel each other, because minus 1 plus 1, that's exactly 0. So we're going to just get n. So this is how we get our n minus 1th number. As we showed in the video for the first problem, you can use the formula, this formula, to find any triangular number. Just replace n with 1, 2, 3, 4, and so on. So we showed how to find. What if we don't know the position? It's not exactly a particular number 1, 2, 3, 4. We know if it's 1, we replace n with 1. If n is 2, we replace n with 2. What if it's n minus 1? We will replace n with n minus 1. So we should have learned this in your algebra class. So now what we're going to do is very easy now. Sn, what's Sn? We know a square number. Pretty much, if you I said we have to use the shape, but we kind of have to have an algebraic form for the square number. So what is the algebraic form for a square number? If you look at it, S2, 2 rows, 2 columns, that's exactly 2 times 2, which is 4. And if you look at S3, we got 3 rows, 3 columns, that's 3 times 3. And if so, in general, when you have n, the nth square number will be n rows times n columns, and that's n squared. So the algebraic form for Sn is n squared. And now, what is Tn minus 1? We just got it right here by plugging into the formula. So we got n minus 1 times n over 2 plus Tn. We use the original formula, n times n plus 1 over 2. So now we use algebra to add the right side. We're trying to show right here, this is something we need to prove. So we don't know if they're going to be equal to each other, left side and right side, but we're going to try to see. Okay, add the right side. The same denominator, 2. So the top, we add numerators. And when we add numerators, we multiply out, distribute n's to both of them. So we get n squared minus n. And distribute n to both of these, we get n squared plus n. Now simplify this by algebra. We know minus n plus n, they will cancel each other. These two will be canceled. So we get 2n squared. Combine n squared and n squared, get 2n squared. And if we reduce n 2 and 2, that's exactly n squared. That's the right side. And the left-hand side, it's also n squared. So when you write on the proof, though, you probably should do it separately. You can, how do you write a proof? So you can say the left-hand side is Sn left-hand side equals n squared. And then right here, you're going to put the right-hand side as equals these. So you find out, okay, the left-hand side equals the right-hand side. So we proved these two are equal to each other.